Okay, I'm making this video to share with you guys everything you need to know about building the generator that will speed up under load and has no magnetic drag. First thing you need to know is it's all based on a video that Matt sent me years ago where he was running a little machine. He was pulsing a stock off-the-shelf motor with a 555 timer, turning a rotor, about a 6-inch rotor with two 1/4 inch thick by 1 inch or 2-inch diameter Neo magnets on it, and he had two big coils. And that machine was putting out more power than it was taking to run. And when you run it on the 3 battery system, I could see the potential. And so I wanted to replicate that. And I thought bigger was better. It wasn't long before I realized that if I put 4 coils on the machine, the magnetic drag was so great that it burnt the motor up. And so that led me down the path of trying to figure out a way to neutralize the magnetic lock. So let's go through this machine part by part. And the first thing I want to talk to you about is the rotor. These used to be my rotors. I had 6 2-inch by a 1/4 inch thick neodymium magnets in the rotor. They were pressed in and they kept coming out. Vibration, high RPM, traction of the magnets to the iron cores of the coils would suck the magnets right out of the rotor. And I had lots and lots of these made. Every one of them was a few thousandths smaller than the previous one, hoping that when I pressed the magnet in hard enough, it would not come out. And I tried super glue, I tried epoxy, I tried everything I could think of, and it didn't work. So I went to this rotor right here. What it is, it's a 1/2 inch rotor. There are 2 neodymium magnets that come. One comes in from this side and one comes in from this side, and there's a thin layer of plastic in the middle. If you look in here, you can see the glint of the magnet right there sticking out the side of the rotor, because these are 1/4 inch thick magnets. And when you put 2 of them into a 1/2 inch piece of plastic and leave some plastic down the center, the magnets can't be flush with the outside. So what happens is that's why there's such a big air gap between the rotors here and the plastic, because as those magnets go around, there's some places in there where they could catch, and catch they do. And when one of those magnets catches on something inside, this rotor blows up, just flies to pieces, and plastic and magnets go anywhere or everywhere. So I had to widen the air gap in order to deal with that, or come up with a different rotor design. Well, on my big machine, which is over here, it's got a much thicker rotor because I'm using thicker magnets, but the magnets are flush with the outside, so this rotor can rub and it doesn't matter, and so my air gap here can be much, much tighter. I think I have a 1/16 of an inch air gap in that machine. And the amount of flux that you get, the amount of energy that you create, it makes an exponential difference how big your air gap is. So getting as tight a tolerance on your air gap as possible is absolutely critical to getting the best production out of your machine. Okay, that's the rotor. So let's go back over here and talk about everything else. I have 2 pieces of plastic here. You could use 2 pieces of wood. What I have is a hole for the coil to go all the way in, and then it can't go all the way through this one because I didn't drill the hole all the way through. I left like a 1/4 of an inch of plastic right here that has a small hole in the center for the core of the coil to go through. That's 1/4 inch thick right there. Now you could take 2 pieces of wood like this with spacers in between, put a piece of 1/4 inch plastic on the inside of it, screw it to the wood with some non-magnetic screws, brass or whatever, and you would have exactly what I've got here. You do not want to use aluminum spacers in here like I use because of the eddy currents they create. You want to use, maybe PVC pipe. You take a stainless steel screw that's long, or bolt that's long with a flat head, put it all the way through, put a nut over here with some Loctite on it so it can't come loose, and allow that bolt head to come in contact with your rotor, and you bolt the whole thing together. Okay, the third thing you got to have on here is, right down here is a great big piece of plastic on the shaft. It looks like this, and the reason for that is when it's sitting there, only this much of the rotor can flex, and I'll tell you right now that rotor wants to flex. It wants to come close to where those iron cores are, and it's going to flex. So the way I dealt with that is this has pins in it that stick out. They go through the center of the rotor, and they go into another one of these plastic pieces that's on the other side. So now I've got one on each side of the rotor, and it keeps the rotor from flexing, and it's tightened up by a nut here. Oh, and this nut has a set screw in it that I tighten up with Loctite, and then another nut and washer over here that I tighten up, and that holds everything in place. So that's most of the component parts. One more thing you need to have is you got to have this plastic plate on top that keeps these from being, these will actually be sucked in by the magnets on the rotor, and they will bend because they're so tall. So you got to have a top plate, and that keeps everything held apart. I think that's everything for construction on this part of the generator, except for why in the world would it have no magnetic drag? Well, this one does. Remember that. And let's take a look at the one that doesn't. First of all, this had 6 magnets on the rotor. I mean, 6 coils on the machine on this side, 6 coils on the machine on this side, 12 coils total, 12 neodymium magnets on the rotor, but they're in pairs of 2 as it goes around. So really 6 magnets on the rotor is what was providing the power. That device, when all the coils were in there, was drawing over 100 amps through this motor, and even running unloaded was drawing 30 amps through the motor, and over 30 amps, and the motor's rated at 27. So you can tell that I burn up a few motors trying to do this, and this is an MY1020, not even an MY1016. So yeah, I burn up a few motors, and so I had to come up with a way of getting rid of the magnetic lock. And here's what I did. The first thing I did is I went from 6 coils on each side to 5 coils. Okay, now that's going to reduce my output, but you got to live with that a little bit. And so there's a bigger space between the coils on this machine than there is on the machine I just showed you. And there's even a bigger space than is needed because I put these pieces of plastic PVC pipe. You can see them right there. There's one of those, a round one, in between each one of the coils. So there's 5 coils, there's 5 pieces of PVC pipe, and each one has a screw coming out of it. Well, what are these 5 screws for? Well, let's flip it around and I'll show you. This PVC pipe has a bolt coming up the center of it. You can see the bolt right there. And what it does is the PVC pipe comes all the way through this piece and only halfway through this piece. It's just enough to go in there, stick in it, and be glued in place. And then in the center of each one, there's a hole drilled for the bolt to come through, but it's a little bigger than the bolt. If you can tell, I'm able to wobble the bolt a little bit. And one of these little units that you can get at Lowe's, it's threaded on the inside, is set into the plastic right here on the other side so that this bolt can thread through it. And on the end of this bolt is another one of these and a lock nut. This is threaded onto the bolt. The lock nut is tightened up. It's all put on there with Loctite. And then this is stuck into a piece of plastic like this that has an indent in it for this to fit in. And so it's in there, and it's on the end of the bolt, and it goes in and out of this tube as we screw the bolt in and out. This piece of plastic goes in and out of the tube. Well, what good is that? In this side of the thing, that little metal piece went on this side. On this side of the thing is a neodymium magnet. It's glued in place in there. It's also attracted to the metal piece that's on the other side a little bit. And if you look in there, there are 5 neodymium magnets in that unit, and there are 5 neodymium magnets in this side. Well, what are those for? Well, here's what they're for. If you look at a rotor, as long as the rotor has an even number of magnets on it, 6, 8, 10, 12, however many you want to put on it, one magnet is always directly across center from another magnet. And so, if you look on the back of the machine, you can see where the coil was, right there with the center hole, 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 and right there. Take a look at the first one. Directly across from the center hole is one of these adjustable neodymium magnets. There's also one on the other side. And so, as the rotor's coming around, and the magnet on the rotor is being attracted to the iron in this core, the magnet that's coming here is being repulsed by the magnet that's in here. So all the magnets on one side of the rotor are north, all the magnets on the other side of the rotor are south, all the magnets in this are north, all the magnets in this are south. So as a north magnet is coming by here, a north magnet is coming by here, and this is repulsing it. And when you adjust this one and the one on the opposite side in and out against the rotor magnet, you're going to get a balance between the attraction here and the repulsion there that's going to neutralize this attraction. And you basically get a freewheeling rotor. When you do that with every one of your coils, your rotor will be left, it'll be a freewheeling rotor, and you'll get everything you want out of it. Now, when you get it all adjusted, if you look at each one of these bolts, they all have a washer, a lock washer, and a nut out here. You tighten it up with Loctite, and it locks everything down, so everything is locked into adjustment, and you get everything you want out of this system. Now, there's one more thing I should tell you about this, and that is coils can only accept so much magnetic flux. So if you want to, put a 12-inch magnet going by your coil, and it's going to accept a certain amount of flux. If you put a 1/4-inch magnet going by the coil, it might accept the same amount of flux, and you've wasted a lot of money on those big 12-inch magnets. So you got to learn how much flux your coil will accept based on the size of the coil that you wound. I started with 2-inch by 1/4-inch thick neodymium magnets because that's what Matt had on the original machine that she showed me. I went to 1-inch neodymium magnets just to see what would happen, and each individual magnet put out 75% of what the 2-inch magnets put out. But because I had twice as many of them on the rotor, because they were only 1 inch in diameter, and so I could put 12 instead of 6, I now had 150% of the output of the original machine. And then I went to 1/2-inch thick magnets instead of 1/4-inch thick magnets, and I found out that now I was back up to 100% of the output per magnet, but I had twice as many magnets. So now my machine was putting out 200% of what the machine with the 2-inch neodymium magnets in it was putting out. And so you got to learn. There's a bunch of stuff you got to learn about how to put one of these machines together. And I'm not done learning. I'm far from it. I'm still experimenting with magnets. I'm still experimenting with all kinds of stuff. But this is where I am. There's this machine here. There's that machine there. There's my big machine over on the bench over there. And I actually have a 4th machine that's this version somewhere in the shop. I'm not even sure where it is right now because my shop is, we're moving. And so I'm a little messed up with my shop. But you can have exactly what you wanted out of this system if you build it the right way, with a razor scooter motor and a 3-battery system, so that you recover 80 to 90% of the power that's put in with a generator that has no magnetic lock, and the coils speed it up under load. You have no excuse. Get off your butts and build the dang thing, and you'll see exactly what I've seen, and you'll know that all of this works just exactly like we've told you it does.